So we're seeing InfiniBand really become a strong proponent for the interconnect for cloud computing, and the reason why is because the bandwidth and latency is, bandwidth is so high, latency is so low, and when you're in the cloud you don't know what applications are going to be doing what, and so you need to make sure that you can provide best performance for what your customers want, whether it's a database kind of application or and then there's hooks in InfiniBand where you can do things like IP over IP or Ethernet over InfiniBand, so you can get some really good performance benefits of your applications who don't know what network it's on, but they get extremely good performance. Now, when you connect that with storage too as well, you can really provide redundancy and some failover features where if something goes down, that's not going to affect the user at all because you can replicate very quickly. What's interesting there in terms of the cloud computing market is that a lot of folks are trying to figure out how can they differentiate their services, and so one of that is guaranteeing performance as part of their SLAs. So now, along with guaranteeing uptime, right, 99% uptime, I can guarantee that you're going to get a certain bandwidth performance your entire session, no matter what the peak time is. And InfiniBand, because of its bandwidth, is something that they can model this criteria on. Moving to the HPC space, it's really interesting to see kind of what folks are going to be doing in the cloud. And here's where InfiniBand is really kind of critical, because a lot of the scientific applications that people are using, they really depend on the lowest latency along with the bandwidth. But now you have a true mean in terms of providing those scientists or professors at universities a tool where they don't have to worry about spending research money or some of their grant money on acquiring clusters that, as soon as they get them, are potentially out of date. Right now, as soon as you buy a server, once it gets to your house, a new server is already being introduced. And now instead of spending money on that, as well as spending money on IT to maintain that cluster, now there's institutions that are out there, or cloud providers that can provide specifically to scientists out there these large cloud infrastructures, which they'll maintain, and all the scientists have to do is just essentially purchase the time. Much easier solution, and in terms of security too as well, obviously there's things that are in play there to guarantee that your data is safe. So we definitely see this as a very interesting opportunity, not only just for InfiniBand in general, but just for how will this make how would this make exploration become that much easier for folks, right? And discovery. You're enabling a whole other generation where they have the SIMs, they just throw it in and they're good to go, and they don't have to worry about systems, costs, and will that fuel further research or increase research? It's obviously remains to be seen, but I think it's a good step.
Maybe one other piece, just to echo on some of the things that Brian's talked about, is that InfiniBand has really matured dramatically over the last 10 years, and we have features like virtual fabric. So even in a cloud environment, we can make sure that specific applications get the sort of resources from a networking standpoint that really guarantees performance, and that really allows a lot of applications to migrate onto the cloud, especially those that are well understood. And even for those data centers that are doing a lot of cutting-edge resources or research, after they get the applications mature and running, those are opportunities to move them into the cloud, and then it frees up their internal resources to be used specifically for cutting-edge leading research. So I think moving forward, the whole cloud computing in the HPC space is going to provide a lot more flexibility, and as Brian pointed out, bring it to a much broader audience.